So let's say you have a list of data and you have like 10, 40, 20, okay, 50, 30, 10, 20, 30, 40, 50, and let's say 60. Right, so this is your list and you want to sort this list, right? So how the sorted list would look like? It will look like, okay, so 10, 20, 30, 40, 50, 60. This is how the sorted list will look like. Of course, you can do dot sort, but obviously we don't want to do sort, right? We want us to manually do the sorting. In the sense, we have to use the logic to sort it. Okay. There are different types of sorting algorithms. One of them is bubble sort. Okay. So how bubble sort works? Okay. So first, let's understand how the bubble sort works, and then we will implement it. Okay. So I'm going to move to Paint. Just give me a second. Okay. So you have so let's say you have let's say 6, 5, 4, 3, 2, 1. Okay, this is the list, and you want to sort it. Sorting list would look like 1, 2, 3, 4, 5, 6. Right? This is how it should look like. So bubble. Okay, and this is how I remember. Okay, BB bubble. Okay, so you compare first element with second element and then check if it is required to interchange or not. Okay. So when you say increasing order, your first element should be lower than the next element, right? When you say 1, 2, 3, 4, so when you compare 1 and 2, 1 is lower than the 2, right? When you compare 2 and 3, 2 should be lower than the 3. That's what we mean by sorted order. 3 and 4, 3 should be lower than the 4, right? So here, is this sorted? If it is sorted, then do nothing. If it is not, then interchange the value. So in this case, when you compare, so this is yours, we call it as, say, uh, uh, first set and first iteration. So when you compare 6 and 5, okay, is and how do you read this? So you will read this as L1 of 0, correct? So if L1 of 0, if L1 of 0 greater than L1 of 1, if L1 of 0 is greater than L1 of 1, then interchange. Okay, that means 5 will go here and 6 will come here. Okay, so that's the first step. Second step, now you compare 2 and 3. That's how bubble sort is different than, say, sequential sort. Okay, bubble sort, you always compare immediate values. Then you compare 1 and 2. Okay, 1 and 2 is 1 greater than 2. If yes, then sort it. If no, then leave it. Then, so what happens? 6 will come here, 5 will come here, right? So after first set and first iteration, 5 will be here. I'll put it in different color. 5 will be here and 6 will come here. Now you're comparing 6 and 4. Yes, you need to interchange. So then 6 comes here and 4 goes here. Now you compare 6 and 3. Then you compare 6 and 2, 6 and 1. Okay. So what happens after end of your first round? You will have 5, 4, 3, 2, 1, and 6. So we say after first pass, first round, your last element is fixed. So you're comparing 6 with 5, then 6 with 4, right? And if the previous number is greater than the next number, then you interchange, right? And you keep doing it till the number of elements are there, right? So if there are 6 elements, how many comparison are you making? 1, 2. So this is one comparison, right? Then 2, then 3, then 4, then 5, right? You're making 5 comparison. After 5 iteration in pass 1 or round 1, you're making 5 iteration and you get your last element fixed. So now second pass. This is first pass, now second pass. Again, you start from beginning. 5 and 4. Okay, previous number, is it greater than the next number? Yes, interchange. So what happens? 4 comes here, 5 comes here. Right? Now you compare 5 and 3, interchange. Then 5 and 2, interchange. 5 and 1, interchange. You don't have to compare 5 and 6 because 6 is already fixed from previous step. So you are in second pass, you are running. So here you are running 5 times. Here you are running only 4 times. And what happens after second pass, your second highest value is fixed. So 5 will be fixed here. And you have to do it how many times? How many passes is required? 5 times, right? Because after 5 times, your second element will be fixed, right? So let's say 2 is fixed. 2 is fixed. Okay. Then in fourth pass, third is fixed. In third pass, 4 is fixed. Okay. In second pass, 5 is fixed. And in the first pass, 6 is fixed. Right? Obviously, 1 is left. Last element, you don't have to compare, right? Last element is auto sorted, isn't it? It is sorted automatically. So this is how bubble sort works. Sequential sort, what you do is, okay, you compare always the first element with second, then first with third. Concept is same, okay? If previous element is greater than the higher this thing, then you interchange. But how you compare is different from sequential and the bubble. So always you're comparing first with second, first with third, first with 4, first with 5, first with 6. Like that you are comparing. Okay. So we'll see how to implement both of these in our Python language. So I'm going back to PyCharm. So how many loop we need? We need 2 loops. Okay. So for I in range, okay. And how many times we should do? Okay. Len of L1 minus 1. So see, if we have 6 element, we have to run 5 passes, right? 6 element means 5 passes. Now for J in range, and here what are we doing? For first pass, you have to remember that star pattern. See, if you know, remember the star pattern in for loop, all the for loop you can solve. Okay, it's the same concept. So what we did, first we are doing, okay, 5 passes, then 4. It's like doing 5 stars, then 4 stars, then 3 stars, then 2 stars, then 1 star, right? 1 star not required, correct? So, or 1 star is required, that is second last pass. Okay, then 0, right? So this is how you decrease. So how do we get, first time it should do 5. How do you know it should do 5? It should do len minus 1, correct? And minus I. So first, len minus 1, 6 minus 1, 5. 5 minus 0, 5. Then 5 minus 1, 5 minus 2, 5 minus 3, right? So this is how you will be able to decrease the number of iteration in each pass. So outer loop is for passes, 5 passes, and this is for number of iteration within that pass. Okay, so you say for I in range, for j in range, len minus 1 minus I, right? And now what I need to do, I need to compare what if L1 of, okay, this is always you're starting with 0, correct? In range 0, 1, 2, 3, 4, 5. First 0, 1, 2, 3, 4. Okay, then 0, 1, 2. So here first time it will be 0, then 6 minus 1, 5 minus 0, 5, isn't it? So it will go up to 4, isn't it? Because when it's a range 5, it will go from 0 to 4. So comparing L1 of J, okay, L1 of J, if L1 of J greater than L1 of J plus 1, next element. If 0 element is greater than 1, next time you will say if 1 is greater than 2. Next time you will say if 1 is, 1 is greater than 2, then 2 is greater than 3, 3 is greater than 4, right? So if L1 of J greater than L1 of J plus 1, then you interchange the value. What you do, you say that L1 of J, now in Python, you don't have to write like 3 variables. You can interchange using 2 variables. I'm saying L1 of J, comma L1 of J plus 1 equal to L1 of J plus 1. This is how you interchange. Okay. So I'm saying whatever value is in J, it will take the J will take the next value. This is L1. Why did you say I? Oh, okay. I think L1 got deleted. L got deleted. Okay. So L1 of J plus 1, the next value becomes previous. Previous becomes next. Interchange. When previous value is greater than next value, then you interchange. Otherwise, leave it. That's it. After this, when you print your L1, print sorted L1 equal to, okay, you have L1. Now you run your program. You see, it has sorted this. 10, 40, 20, 50, 30, 60 sorted into 10, 20, 30, 40, 60. Okay, so this is the logic. Now this is your bubble sort, right? So this is your print bubble sort. Now what I'll do, I will again say L1 equal to this. And I'm going to copy this. And here I will say selection sort. Now, number of iteration remains same. Now, what happens here? You are comparing first element with second, first with third, first with fourth, so on, right? Now, your first elements gets fixed in selection sort. In bubble sort, last element is fixed. In selection sort, okay, let's see that. Okay, let's go to paint again and we'll see how one pass occurs. So I'm going to, let's say, delete this. Let's say same values we have 6, 5, 4, 3, 2, 1. So now you're comparing. Now you're comparing 6 and 5. Okay, 6 and 5. Do we need to interchange? Yes, right? Previous value cannot be greater, right? So you interchange. So what happens? It becomes 5 and 6. Now you compare first with the next element, 1 and 4. Yes, 5 is, so and first position becomes 5, then you have 4. Yes, you need to interchange. So this becomes 4 and 5 comes here. Now comparing 3 with 4, yes, 3 comes here and 4 comes here. Now you're comparing 2 with 3. Yes, so 2 comes here and 3 comes here. Now you're comparing 1 with 2. Again, interchange required. 2 comes here and 1 comes here. So in selection sort, after first iteration, your first value is fixed. Now we have to start with second, okay, with 3, second with 4, second with 5. Same thing you have to do, right? So let's go back to our program. So in this case, we don't need to use J because here we have 0, right? So 0, 1, 2, 3, 4 will work. Now, in the J, so this is your L, sorry, not 0, you have to do I, right? Because I is changing from 1 till 5, right? It will go on up to 5. Is this correct, or should we have, do we have to change it here? Should it go to, so we are going, if there are 6 elements, it's going up to 4, right? Yes, it should go up to 4 because you're not comparing last with last again, right? Okay, so here I should be there, and interchange, it should be I. Now you see, how does J work here? Okay, now here we saw that, okay, J should start with 1 and go up to the last element. So since we're going up to last element, you have to say, if it is 6, you have to go up to 5. But here, you don't have to start from 1. You're starting from, like, not from 0, right? You're starting from here, 1. So I'm saying 1 plus I. So first time, it will start from 1 plus 0. So it'll start from 1 and go up to the last element. Second time, you're starting from 1 plus 1, 2, because first element is fixed and second element you are comparing it. I will have second element. So you need to go to third element and start, isn't it? So that's why we say 1 plus I here. Okay. Now, this is your I and this is your J. You don't have to say J plus 1 because we are going to up to last element, right? You just compare I and J. I and J. And if change is required, you change with. So what is I? I will take J value, J will take I value. That's it. You see, it has sorted. And if you want to really, I mean, you want to check if it has done all the steps or did it miss any steps or not. So instead of saying like this, you give L1 as a totally reverse step. So if you give totally reverse, then it has to execute all the steps. Okay. So you say 60, 50, 40, 30, 20, 10. Okay, and that's what I'm going to do here as well, just to make sure that all the steps are executed. Otherwise, what happens is maybe last step, because 60 should be at the last. What if the last step is not executed properly? But luckily we have highest value at last. So even if it doesn't execute, it is giving correct answer. But now if I put value like this in reverse order, it has to execute every step, isn't it? That's how you test your program. So even this is called worst case scenario. Worst case scenario is that every element is replacing every step. Okay, there is no step where there is no interchange. Correct? So this is like your program is going to take maximum number of steps to execute. And you see, even if I give the worst case scenario, it is giving us the best result. Right? So best case is the element is already sorted. If element is sorted, then this if will never occur. And if it is in reverse order, then every time your if is occurring, right? So that's the way to test your program is executing correctly or not. So this is how your bubble sort or your selection sort will work. And there are a lot of sorting, not just do you have merge sort and insert sort. Okay, they all have different logic. So it is an application of your list itself, or you use it for different sorting, searching, right? In searching, you have again sequential search or what is that? Uh, what is that searching called? Where you look for the mid value. What is that searching? What is the search technique called? Where you look for the mid value? You know? Searching you have not done.
Sir, can you repeat?
What are the search technique? So one is sequential search, other is called binary search. Okay. So I want to search. I want to search for a value in this list. I want to search if 55 is there in this list or not. I want to search if 55 is in the list or not. So one way is you look at key, okay, or element to search, right? Element to search is your 50, let's say, or 55, correct? And let's say this is your L1. And I want to search if 50 element is in list or not. So I'll say found equal to 0 or found equal to false. I'll set it to false. And now I will iterate through this. So for I in, instead of range, I will say L1. For I in L1, if, okay, element equal to I, right? If element is 55, if element equal to 5, then you say found equal to true, right? And after for loop, you can, you check if found true, then print element is in the list. Else, you say print element is not in the list. Okay. And so when you run it here, element is not in the list. If I make it as 50, okay, you'll say element is in the list. Okay. So, okay, so this is how you do in Python, because Python, you can actually go through the element, but generally in C, C++ or Java, right, you cannot get access to this element. So what we do there, okay, so we, okay, we do same stuff here, and, okay, sequential sort method 2. So you don't have to go through L1. So you will say range of len of L1. So now you are not going through the elements of the list, but you're getting 0, 1, 2, 3, 4. So instead of I, you get L1 of I. That's the only difference. Okay, you're not getting access to element, we're getting access to the index. So I'm checking L1 of I. Okay, so element is in the list. Okay, so this is called sequential. You start from 1, okay, 1, 2, 3, 4, you do, right? But this is not the preferred way of sorting. What we prefer is binary search. Okay, this is called searching, not sorting. So this is sorting. Sorting means you're arranging your value is in either increasing or decreasing order. By default, it is in increasing order. By default, it's in increasing order. But you can set it in decreasing order too. Okay, that is your sorting. Searching is you are searching if an element is in the given list or not. Right? So how binary search work? Binary search, first you have to sort the element. Binary search works on sorted list. So you have to first sort the list. And then what you do is you go and check at the midpoint. So if I go back here, and I'm going to share my paint. So let's say you have, so first you have to, sort the list. Okay. Let's say you have sorted. So you have 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's say this is sorted list. Now I'm looking for, let's say 8. I want to find if 8 is in the list or not. So what you do, you look at the size. Okay, what is the size? 9. So go to the midpoint. So 9 by 2. What will 9 by 2 give us? Integer division will give us 4. So position 4, 0, 1, 2, 3, 4. This is position 4. So you go to the mid value of the array or the list. Okay, so you go to the mid value of the list. So there are 9 elements. So 9 by 2 is 4. You are going to the fourth value. Now you compare. Is this equal to the element? No. We are looking for 4 or 8, right? We're looking for 8, let's say. So what you do is first you bring your start value, or we call them as low value, and then this is your high value. Low value will always point to the first value in the list, so which is L1 of 0, and the high value will always point to the last element of the list, which is L1 of -1, right? Okay. Now your key will be, the mid value of this. So len is 9, len by 2 is 4. So this is called key. So now your key or mid value, right? We'll call it as mid. Let's say now if mid value is equal to your element, then you say found. If not found, then you're comparing this value that you're looking for. Is it greater or smaller than the mid value? If this value is greater, that means element will be on the right side, correct? And if, let's say, if you're looking for 2, that means your value is on the left side. So now if the element is higher, your high will remain same, but low will come to midpoint. Okay. And if you're looking for 2, so 2 is what? 2 is lower than the mid value. When it is on the left side, then your high will come to the mid value here. Then high will come to your mid value. Now, if high comes mid value, again you look for the mid value of these two. Right? So this is how you keep finding the mid value, mid value, mid value. And when your low becomes greater than high, or high becomes less than low, that's when you stop and you say value not found. Okay, if found, then of course you can exit from the loop. You don't have to continue further. And we can do the same case here also, right? In this case also, if found equal to true, you can break the loop. You don't have to continue, right? You found and you can break from this loop. So what happens here? Let's say we need sorted list. So let's say we take sorted list here like this. So this is your sorted list, and I need to go from left to right. So initially your low, comma, high is L1 of 0, comma, L1 of capital L, right? L1 of 0, comma, L1 of your len of. In fact, you don't have to do this, okay? We directly take the index only, okay? Because when you're comparing, we can check L1 of low or L1 of high. So 0, comma, len of L1 -1, because len1 will give you higher than this, right? So you have 0, 1, 2, 3, 4, 5. So your len will be 5 minus 1, 4, right? This is the index. So your high will be len1 -1 and low will be this. And then you have mid value, correct? Let me put it complete so that we might ourselves get confused, right? So, okay. And mid is low plus high, okay, divided by 2. Right? Okay. Okay. Now, the element that you want to find, let's say element is 50. First, we'll put something that is there in the list. Let's say, or you put 60, even better. 60 or 10 will be the worst case because you have to go all the way to the last step, isn't it? Okay, so element equal to 60. And so I'll say while, okay, here we will not use for loop, we'll use while loop. While low is less than equal to high. Okay, So as long as low is less than or equal to high, we will continue. The moment it becomes reverse, our for loop will break. Okay. And again, I will say found found equal to false, right? Initially it is false. The moment we find it, we'll check. So low is less than high. Now we have already calculated mid. We don't have to calculate mid here. We can calculate mid inside the loop also. Okay. Now, if L1 of mid equal to your element, then found equal to true and you say break. Else not found. Okay, so you calculate the mid value and your mid value is not same as your element. Then what we do? Okay, then we will check if element is greater than mid value or less than mid value. So if element greater than L1 of mid, perform certain logic, else perform certain logic. Okay, so now let's look at this logic. So element is greater than mid value. That means your value is on the right side. Value is on the greater, right? Element is greater because it's always about sorted list. So if element is greater, that means your element is on the right side. If your element is on the right side, then your low will come down to the mid value. So what happens? Your low becomes mid. That means if mid value is 4, low which was 0 will now become 4. Right? And if element is less than L1, that means it's on the left side. So high will come down and your high becomes mid. Okay. So this is how binary search is done. And I'll just copy and paste this found logic. Right. I'll paste it. So this is your called binary search. Okay. So run it. Element is in the list, 50 is in the list, right? So it says list in the list. Now, if I make it 60, right? 60 is in the list. Now I can even put this, right? And I'll put F, and I'll say element. Right? I'll copy and paste here. Why this is not executed, not completed? Why is it still okay? If L1 equal to element, okay. Something is wrong here. Oh. Okay, this loop has running. Okay, this loop is running forever. Okay, so if I say equal to, this is not giving output, guys. See, no bubbles are. It's actually entered into infinite loop. It has entered into infinite loop. Why? Low becomes mid. Okay, so instead of mid, because mid element is not there, right? So we will say mid plus 1. And high, we will go one step further. Mid value is not matching, right? So we'll go one step further. Okay. Now let's say, yeah. Okay. So what happens was when we are giving same, right? It's stuck, it's not got stuck at the same value. So we are saying if mid value is not there, then you make it one more than the mid value. And here we are saying make it this one less than the mid value. Okay. Now, if you give 50, Okay, it says 50 in the list. Now, if I make it 51, let's see what happens. It's not in the list. So this is how your binary search works. So dividing the group into half, 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 half. So dividing into half and then deciding which half to look into. Again, dividing into half and looking which half to look into. Right? And this is how you'll be able to perform binary search. All right. Any question? Yeah.
Sir, can you explain the else part again?
Else part. Which else part? This one.
Yes, sir.
Okay. Let's go to paint. Okay. So what we did, we are doing 0 plus whatever 9 by 2, 4. So your mid value is A of 4, correct? Right? Not this 4. So let me do it again here. Okay. So element low will be initially to start with, low is here at 0 and high is at your len minus 1. Len minus 1 is 9 minus 1, 8. So this is your L1 of 8 and this is your L1 of 0. So first iteration starts with 9 by 2, which is 4. So this is your 4. So this is your mid value. So comparing, is this the number you're looking for? No, this is not the number you're looking for. Then 8 means your value is in the right side. So what I'm saying mid plus 1. Earlier was bringing L to the 4. That's when it got wrong. I'm saying no, I don't want. 4 is anyway not in the, is not the number. So L1 should come to 5. So that's why I'm saying mid plus 1. If you're looking for 2, then you'll bring high to mid minus 1. You're bringing high here, not here. So bring high to mid minus 1, or you bring low to mid plus 1. So if it is 4, then 4 plus 1, 5. It will now point to 5th index or your 6th element. Right? This is what we are doing in the else part. Right?
Okay, sir.
Any other questions? Okay, so let's move on to files. And we did half files, right? We just have to do couple of more methods. So first thing, you give the file name, right? And what was the file name that we gave? We gave 17december.txt, right? We say 17december.txt. This is the file. So now you say file object equal to open. Open, you give the file name. And then you say the mode in which you want to open, right? So you have RWA, R plus, W plus, A plus, right? This is what we did. Let's say I want to open in A plus. Okay. So I want to open in A plus. So this should be in quotation. So you say A plus. Now you double click on this file, you can see the content that we have. So this is the content in your W plus. So this is your first line, second line, third line, fourth line, so on. Okay. Now I want to, okay, so when you create the file object, you have to always close it, okay? And all your logic will be between open and close. Okay. Okay. Now we need to read the content, right? So I'm saying content equal to file object dot read, right? So here it'll say slash n, comma, content. Okay, so I'm reading the content here. Now again, I want to read the content. Okay, second time I want to read the content. What will happen? So first time,
Sir,
okay,
the screen is.
not shared. Oh, sorry. Now you can see.
Yes, sir.
Now you can see, right? Okay. So now what happened? Okay, content is not this, sorry. 17 December. Content is there. But when I say read, what happened? Did you get the content output here? No. Right? Why? Since you have said append mode, it is in right. Now, if I put this in R plus mode, right? So you see, it is able to read. You can also write. Plus means you also write. But when I opened in A plus mode, okay, it's ready to append. Where do you append? You append at the end. So cursor went to the last position because it is expecting you to add the content. If I tell you, okay, join two or tie two ropes. The moment I say tie two ropes, okay, you will go to the end of the rope that you are holding. You'll say, okay, give me the other rope. Because I'm saying to tie it, so you'll tie at the end itself, right? I'm saying append, so it went to the append. Okay, so it is, so that's why when I say read, okay, it is at the end. There's nothing to read. So you didn't get anything there. And now after reading one time, again you are at the end now. I'm saying read. You read the entire thing. After reading entire thing, you are again at the end of the file. So to come to the beginning of the file, I have to use what is called as file object.seek, right? Seek and you give the position. I'm saying 0. That means I'm saying come to the first character, first position. Now you can read when I don't mention anything here, just simply read, no parameter, it will read the entire content. If I say 20, it's going to read only 20 characters. So it comes to the beginning and then it's reading only 20 characters. Now if I again do, what happens? Do you get any output or not? I'm saying third time. Do you get any output or not? Yes, you do get, because after reading 20 characters, you are at here. So next time when I'm saying give me 20 more, so see LITT is here. So LE, it's going from there. Little star high 100. So next 20 characters you are getting. Okay. Now again, I will set file seek to 0. I'm going to the beginning of the file. Okay. And here I will say read line. Now, when I say read line, it is going to read only one line. Okay, read line means it's going to read only one line. Twinkle, twinkle, little. That's the first line that you have here. It read the first line. Now, again, if I say read line, I'm not changing the content pointer. So what it does, it will read the second line now. So 5 is reading second line, right? 5 is reading second line. Great. Now, if I say read 5, just like read, I gave some character. Read line also, I'm saying 5. That means I'm saying read 5 characters. Obviously, from in current line, because read line will always read current line only. So it's reading 5 characters from your line number 2, Hawaii. Now, if I say 5,000, do you think it will read all the characters? No, because okay, 5,000 I should give here, no? Okay. Will it read entire thing? No. Why? Because the scope of this is to read only one line. Okay. You are not allowed to go out from your home. And I'm asking you to read, run in a straight line. In your house you are locked, so if you're reading, if you're running in straight line, you will run from one room to another room. You cannot run a kilometer, right? If your house is not as big as 1 kilometer, right? You will not run 1 kilometer because you're confined. So I'm saying read lines. So it is confined to read only one line. If you give, okay, run give me 5,000 characters, from where will you get 5,000 characters? The line itself has maybe 50 or 100 characters, maybe, I don't know, 50, 60 characters. It can't give you more than 50 characters. Even though you're saying 5,000, if I say 5 or 10, if I say less, then it's fine. It can read only less characters. But even if I say more, it cannot read more because limit itself is so many characters. So this is how you read one line, multiple lines, multiple characters. And read lines. Then you have something called as read lines as well. Now, read lines means you are reading multiple lines. Okay. So I'll do again file seek. So that I'll go to the beginning. I will say seek 0, read lines, and I'll say here 6. And I'm saying here read lines, correct? Now, when I say read lines, it will read entire lines, but it will read them as list of each line. So see, first line /n, second line /n, third line /n. Okay, so you can read multiple lines, but all of these lines will be read as a list of those lines. Okay, so similarly, you have write. What I'll do is let me close it, and then I will open file again. And this time we will open file in W mode only. Opening again in write mode. Okay, so we have opened it, so we'll close it. Now, when you run it, what happens? All the content will be deleted, right? Because we open in write mode. When you say write mode, nothing, right? Everything is deleted. Now, if I run it, so all these things will be blank. There's nothing here, right? Got deleted. Okay. Now you have write lines and write. So if I create a content here, like triple quote, I can give multi-line, correct? What I'll do is I will copy this code itself, right? This, let's say, let me copy this entire code here. Code is also a text, right? So I'm saying content equal to this. Now I need to write to the file. So I will say file object dot write. Now see, write has 3 options. Writable is to check whether we can write or not. Yesterday we checked, right? If you open in R mode, then writable will be false. You open in W or A or W plus or A plus, writable will be true. In R mode, it will be false. All the other mode, it will be true. So writable is to check whether you can write to the file or not. Okay. Then you have write and you have write lines. Okay. Now write lines is like your read line. So write lines will only take values as a list. Write lines will take input value as a list. Content should be in the list. So here we have a write, correct? So we will write. And now when you run it, oops, file object, write content, right? What should it write? It should write content. So I'm saying write content. Now you see here that entire code has been added, right? Now we go back and we run our program. So see, the entire content has been read as a list. So what I'll do, I will copy this and okay, here I will put another content equal to this one. This is your list, right? I can put it in multiple lines if you want. What happened? I think I hit it wrong, this thing. So I'll hit close here. Here, right. Okay. So same content I'm giving in list of the text. So now when you say file object dot content, so now this content, if I put it like this is a list, right? So I cannot put it like that. I have to say write lines. I'm writing multiple lines. Now when you run it, okay, you go and you see, this was our first set of content. And this is our second set of content that got added here. So that's how you can read and write to a text file. So you have read, readable, read line, read lines. Here you have write, writable, and write lines. Okay. So you can read the content to a file and you can write the content into a file. Append or write. Append will keep on adding. Write will clear everything from past and write new set of values.